Everyone, so today we have another problem, which is maximum number of case and pairs Leetcode medium. Okay, so we go through this flow and understand this problem. Okay, so let's first understand the problem statement. So the problem statement is, we have given an array which is nums and an integer k. In one operation, what we can do, we can pick two numbers from the array and that two number having some k, and we can remove that array, and we have to return the maximum number of operation we can perform on the array by doing this operation. Okay, let's come to one test case so that we can understand it. Okay, so you can see this is the array we have, and these are all the values. So what we can do, we can remove two values from the array such that its sum is equal to the 6. So now you can see, if I remove 3 and if I remove 1, so 3 plus 1 is equal to 4, which is not equal to 6. So we will not encounter this. Now if we take this 3 and if we take this 3, so 3 plus 3 is equal to 6. So this is the one operation I did. Okay, and after using it, I have to remove this. Now if I take this one and if I take this 4, if I take this one, if I take this 4, it is 5, which is not equal to 6. Okay, now if I take this 3, so 1 plus 3 is 4, which is also not equal to 6. So we will not take this thing also. Okay, now we can go inside, and if we take 4 and 4 is added with 3, so it is equal to 7, which is not equal to 6. So we are not able to encounter it. And if we take 3, there is no other elements, we can create pair, and that's why our answer is 1. Okay, we can take one more example to understand it more clearly. So let's suppose our array consists of 1, 2, 3 and 4, and our k is equals to the 5. In that case, if we take 1, okay, and if we add 2, then it is not equal to the 5, it is 3. And if we take 3, then 1 plus 3 is equal to the 4. If we take 4, 1 plus 4, it is equal to 5, which is equal to the k. Then our first operation, then we get one operation. Okay, now we can remove this one and we can remove this 4. Similarly, we can start from there, from 2, and we can see 2 plus 3, 2 plus 3 is equal to the 5, and this is the another operation we get. Now we can remove this. Now everything in the array is used, and this is the answer. This is the total number of operation that we have. Okay, now let's come to the approach how we can solve it. We can solve it using the same thing, okay, as I discussed above. How? Let's see. So let's take an example of array. So 1, 2, 3, 4, 5. Okay, and let's make k is equals to the 6. Now you can see, first ever we are talking about the brute force. So what we want to do, let's suppose if I take 1 as my first element of pair, then in order to find the next, what we can do, we can iterate the other elements and we can check whether the sum of that element is equal to 6 or not. Let's see. 1, okay, then if we take 2, is it equal to 6? No. Then we take 3, so 1 plus 3 is equal to 5, it is not equal. 1 plus 4, sorry, 1 plus 3 is 4 and 1 plus 2 is 3, so it is not equal to k. But when we add 5, we are getting 6. So this is the first thing. So we can take some counter and increment it by 1. Initially it is 0, and then we can increment it by 1. Now another question comes in. Now you can see we use 5 and we use 1 in order to create one pair, right? Now when we iterate next time, how we can understand if this element is used or not. In that case, what we do, we can basically, when this pair creates, we basically change its value by another value and we can use it as a flag. Okay, let me tell you. So what we do, now we can see this 1 and this 5 is creating one pair, so we can make it minus and we can make it minus. So when we come next time, we will check if the value is negative, then it means it is already used and then we can't use it. So let's see the next iteration. Now we take 2, okay, then we add 3, it is equal to the 5. We also check if this 2 is positive, yes, then we can take it. If this 3 is positive, yes, then we can take it. Otherwise, we can't take it. Similarly, this is 4. 2 plus 4 is basically 6. Yes, we can take it. 2 and 4 both are positive. So we can increment our counter by 2 and also make it negative. Okay. Let's move further. Now this is 3. Now you can see this 4 is already used, this 5 is already used, and we don't have anything, right? And in that case, the answer we get is 2, and we can return it easily. Now let's talk about the time complexity. So the time complexity here is big O of n square. Why? Because at each point of time we are creating one pointer and then we are iterating the rest of other elements. So for one element we are iterating n minus 1 element. Okay. Similarly, we are iterating the n element, and for each n element we have to again iterate n minus 1 element. That's why the time complexity is big O of n square. And we talk about the space complexity, which is big O of 1, right? Now let's come to the tip part. So as you know, in the today's problem, we come up with a solution where the time complexity we go of n square and the space complexity is we go of 1. Now you know the time complexity is, the time is very important as compared to the space. We can buy the space, but we can't buy this time. That's why when that type of case arise, in that case, try to use some space and decrease the time complexity. Now if you see the tip, so the tip is, whenever you are trying to solve some problem, you have to think, can we use a different data structures which help us to remove or decrease this time complexity. Okay, so for the today's problem, first let's see where we have the problem due to which the time complexity increases. So you can see for each element we are iterating in order to find the other element. Like when we take one, what we need in order to create a pair which creates 7. So if we do 6 minus 1, which is 5, we actually need to find 5, right? And if we have some data structure which tells us whether 5 is present in this array or not in very fast, then it is very helpful for us. Okay, you are right. Now we can use Hashmap here. So we can use Hashmap here, which is the second approach. We are trying to solve it using Hashmap. Let's solve it. So let's take an array, and array is 1, 2, 3, and 4. And let's suppose k is equal to the 5. So first of all, let's create a hash map. Now we take 1 as a key, and how many times it repeats? It only repeats 1. Now we can take 2, it repeats once, 3, it repeats once, 4, it repeats once, right? Now what we can do? We can create a counter which is initially 0, and we are pointing at this point. Now we will see 1. Okay, now there is a frequency of 1 which is 1, and 5 minus 1 is 4. Now we can check in this hash map, is 4 is present? Yes. Then what we can do, we can simply increment this counter by 1 and also decrement it by 1. So minus 1 is 0, minus 1 is 0. Now let's come there 2. So 2's frequency is greater than equal to 1. Yes, it means we can consider it. So 5 minus 2 is 3. So 3 is also present and its frequency is greater than equal to 1. It means we can encounter it and we can also decrement it by 0. When we reach 3 frequency is not greater than equal to 1. It means we can't take it. And when we reach 4, similarly for that case, in that case, this is the solution for us. Okay, let me take another test case in order to understand one more case here. Okay, so let's suppose 1, 1, 3, 3, 2, 4. Great. And the k is equal to the 6. So in that case, let's create the hash map first. So 1 is occurring 2 times, 3 is occurring 2 times, 2 is occurring 1 time, and 4 is occurring 1 time. Now, as you can see, this is the 6. Okay, this is the 6, and if we divide 6 by 2, we get 3, right? It means if there is some element which is 3, okay, and in order to create 6 or in order to create this value, what we need to do, we have to add again this value. Okay, so whenever this case arises where k by 2 is giving us the value which is present in this array. Okay, let's suppose 6 by 2 is equal to the 3, and you can see 3 is present in this array. In this array, what we can do, we can simply use one formula, which is minimum of count of k and count of k minus whatever the value we have. Okay, so if we see count of k means what? K means 6. So okay, one more problem here. Here we have to write x. Okay, so count of x means 3. So 3 is occurring 2 times, right? And k minus x is also 3. It is occurring 2 times. So the minimum value is 2. So whatever the value we are getting, we can divide it by 2. Okay, and we are getting what? 1. So these are the total number of pairs we can generate for these type of values. Okay, so now we can go and check it, how we can solve it. Okay, now what we can do is we can simply go here for 1 and we can check 6 by 2 is 3. So this 3 is not equal to 1. It means we this is not that case. Okay, this is the another case. So what we can do, 6 minus 1, which is 5. So we can check in our hash map, 5 is present. No, in our hash map 5 is not present. You can see here. Okay, so counter remains 0, right? And let's go next 1. So it is the same case. Let's go next 3. Now you can see when we get 3, 6 by 2 is 3, which is equal to the 3. It means this is the case. And here we solve like same. We get the counter of 3 and count of k minus x, which is also 3, which is 2, 2, and its minimum value is 2. And we can divide it by 2 and we get 1. So whatever the value we are getting, we can add it in the counter. Now 3, after doing this, we have to make our hash map as 0 because we used it. Now we go next, which is 2. So if we do 6 minus 2, which is 4, so you can see 4 is present here with occurrence 1. So we can use it and we can increment our count by 2, and after incrementing it, we can decrement, like it is 1, 0, and 2 is occurring 1 time, so it is also 0. When we go next, so 4 frequency is not greater than equal to 1, that's why we can ignore it, and we get the solution. Okay, now let's talk about the time and space complexity. So if we talk about the time complexity, we are doing one iteration, which is we go off n, but to store these values, the space complexities, we go off n also, and that's how by using some extra space we can decrease our time complexity. Now it's time to see the code, how we can code this. It is very easy as that. Okay, so if you see this part here, we are creating one counter dictionary, and here we check for the case. Let's suppose k is 6 and the element is 3. So if we do 6 by 2, it is equal to 3. So if that is the case, and we also check it is like 6 by 2, this one is even number, that's why we get the value. For odd number, let's suppose 5 by 2 is equal to the 2.5. So these type of values we can't consider, that's why we have a check. We get the pair and we are adding it to our answer, and then make our counter to be 0. It means we don't consider it for the next time. In the other case, we will check if k minus I is present in our dictionary. If it is, we can increment our count and decrement the counter for that, and at the end we can return the answer. I hope you understand this problem. If you like this, please share with your friends, and you can comment out. And if you want to learn some concepts, some data structure, you can comment out also. Thank you.